Welcome to Section 3, Geospatial Processing with the Tidyverse Library, an SF package. In this section, we will acquire census data for the city of Vancouver from an application programming interface, clean and analyze the data with modern and efficient libraries using Tidyverse and SF, visualize the population distribution on an interactive map, and create statistical outputs from the census data. Tidyverse and SF are among the most popular and highly used packages in the R community. Tidyverse is an opinionated collection of R packages that support the full workflow of data analysis with easy-to-read functions and consistent syntax grammar. SF is a new geospatial package developed from the original ST package that supports efficient geospatial processing and can be integrated with Tidyverse for a complete set of spatial tasks. We begin the first video of the section with data query and acquisition from an API. What is an API? It stands for Application Programming Interface. It allows communications and data query from computer programs and saves the manual process downloading and updating a large amount of data every time there's a change in the dataset. So in this video, we will use R to query census data from an API using the CAN census library, explore and filter the spatial dataset to study the population distribution of the city of Vancouver, plot out a map, and finally output the queried data as a local spatial file for further steps. Let's first install all the packages that we need for this analysis. After that's done, we will highlight all the functions with library and run them. We now will need to acquire an API key provided for free from the CAN census website. After your registration, head to the main page, and on the top right corner, there's Edit Profile option, and that's where your API key is. Paste it in between the quotation marks and change the path to store your census data, and that sets up our environment for further queries. We can look at the available census information for Canadian Census 2016. All available information are coded and explained in this table in the Details column. We can select entries under the Vector column and query accordingly on the API. You'll see in the next function, we're selecting vectors of interest and downloading it. Once that's finished, take a look and explore the dataset. The last column contains spatial information and is obtained by specifying the SF geo format in the getCensus function for geospatial processing later. You can find the downloaded data in the file path that we previously specified using the options function. We saw just now that the column names are quite complex and a bit messy, which is troublesome for the computer to process. We will simplify and change the names without any space in them to a more consistent and machine-readable format. Now if we go Names to Data Frame, we can see that the names are tidier. We can plot out the spatial file that we just acquired using the base R plot function, and that shows Greater Vancouver census tracts. Now we want to only focus on the city of Vancouver, and that's why we want to filter our data using the region and unique ID for census tracts. This filter function takes logical arguments and retains regions that are named Vancouver or the census tract ID that contains the specified value. And that's the filter result. Plotting every column in the filter data frame, we can output this spatial file to our local drive using the stwrite function and specify the file in the R memory that you want to output and output file location. And here it is.